because it creates confusion. Okay, so let's take a look, okay, of this one. Is that okay? So let's call X is a set. So we are going to select all the special set X such that X is not an element of X itself. Well, so this is a set builder notation, right? So in that sense, what will we contain for X? Okay. So 1, you can put it here. Because 1 is not an element of 1, right? 1 is not an element of 1. Only 1 is an element of 1, right? Is that okay? Is that okay? So you can put 1 here. You can put 1, 2 here. You can put 3 here. Or 3, 4 here. Whatever. You can put a lot of things inside here. Am I correct? Okay, so far so good. So far so good. But there is something wrong. Okay, so for us it looks like this is, we can define a set like this. A set that contains all the different kinds of sets that does not contain itself inside. Is that okay? Okay, but now Bertrand Russell, he looked at things differently. So look at this. This is a set. Am I correct? This is a set. You are defining a set, right? So let's call it S. Let's call it S. Let's call it S. The question is, this set, will it be inside, or you cannot have S inside? Because S is a set. You can talk about whether S is inside this S or not. Does that make sense? You can talk about this set containing 1. Should be put inside. The set containing 1, 2, it should be put inside. But how about the set S itself? Can it be put inside here or not? Okay, so this is the question that Russell has asked. Is that okay? Okay, so let's take a look. Okay. So there are 2 cases actually. One is S is not inside S, and the other one is S is inside S. Is that okay? There are just these 2 different cases. Okay? Now, if S is not inside S, so if you cannot find S inside, then what will happen? What will happen? Then S satisfies this rule. S is not inside S. Am I correct? And then what will happen? You will put S inside. So if you cannot find S here, then S satisfies this rule, and you should put S in here. So if S is not inside S, then you will put S inside. Does that sound crazy? Yeah, crazy, yes. So that means that you get a contradiction, you get something wrong here. You start with S is not inside S, but then you have a conclusion that S is inside S. So this cannot happen. Is that okay? Okay. Now similarly, how about S is inside S? Now if S is inside S, then that means what? That means that S has to satisfy this rule. And in that case, S is not inside S. Is that okay? So if you start S is in S, then S has to satisfy the rule of being chosen to be in S. So you must have S is not inside S. And that's something wrong. So in that case, so you cannot have S inside S, or you cannot have S not inside S. This rules out of all the cases. So what does it mean? It means that this S cannot exist. You cannot define a set like this. This is not a set. You cannot define it. Okay? So that means that even when we talk about things that are so simple, set notation, set builder, collect things, elements, everything, these are very, very simple things. You can still create some problem with it. Okay? So this is one of a paradox. And then I forget whether I've talked about the Barber's paradox already. Have I talked about Barber's paradox in this class? So there is a village, there is a barber. So barber is people who cut hairs for the others. Have I talked about this already? No, not yet. Okay, good. Okay, Coco, please come out to be the Baba. Okay. 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 So I'm asking Coco to help. Okay. Okay, Coco is the village only Baba. Okay. Okay. So cuts hair for the others. But he has a strange rule. He has a very strange rule. So what is your rule? Do you remember? No. Okay, I tell him. Okay, he told me last night. Okay, before he's drunken. So his rule is like this. He says, so he lives in this village. Okay. He says that for those people who don't cut the hair for themselves, he will help him or her. Okay. On the other hand, for those people who will cut hair for himself or herself, he will never help him or her. Does that sound okay? Yeah, it sounds quite natural, right? If you can do this, I won't help you. But if you can't do this, I will help you. This makes sense, right? Makes every sense. Okay, are there any problem? Okay, this is the problem. There is something wrong. There is something wrong. Yes? Anyone? I heard. Yes?
Cut himself.
Cut himself. Okay, good. What happens? He is living in this village, so his hair grows, right? So what will happen? Can he cut for himself? So he make this rule. Okay, can he cut for himself? Can you? Yes. Okay. If he cuts for himself, okay, good. He says yes. Okay, but I'm telling that no, you can't, because he's cutting for himself, right? He's cutting for himself, but he makes a vow. He says that everyone who cuts hair from himself, he won't do that. So he cannot cut. Okay. Before he wants to make a cut, he cannot cut. Okay. Okay. But then suddenly there is something wrong. Before he gives up, he cannot cut, right? So he is the one who cannot cut hair from himself. He wants to cut it. And then he gets into something called infinite loop. Cut? No, you can't. I can't. But then you cut. Okay. Then in that case, so thank you, Coco. So in that case, there is something wrong about what he's saying. Okay. He's making something that is too strong to include himself inside the argument, inside the restriction. So in that sense, there will be something wrong. So this is having a similar flavor as this Russell's paradox, right? So you try to define a set, but when you define this set, you have not thought about whether yourself is a set or not. But it turns out that yourself becomes a set, and then people will ask whether you will be contained or not contained inside yourself, whether you are being restricted here. If you have some kind of restriction on yourself, this is called self-referencing. So you refer to yourself, then you create a problem. Okay? Okay, so Baba's paradox is one of a similar paradox that we have. So today, let me just give you another one, and then we end up the class early. We try to end the class early. So there is another one. There are two. Okay, so there are two. Let me call this paradox first. This is called the Grayling-Nelson paradox. So this is the Grayling-Nelson paradox. So Grayling-Nelson paradox. Okay. So this talks about English. Okay. So paradox not just appear in math, it also appears in English. Okay. So some people. Okay. So look at it. Some adjective. Short. This is an adjective, right? This means short. And this word is on average, among all the English words, this is relatively short. So this word short, you can think of this as short can be used to describe itself. Short is a short word. Does that make sense? Short is a short English word. Okay, on the other hand, if we look at long, long itself is not long. Okay, so long is not a long word. Okay. So we can okay. So in that sense, we can divide all the English adjectives into two classes, into two groups. One can describe themselves, and one cannot. So this side is the English word that can describe themselves. For instance, short, it can describe themselves. Okay, short is a short word, right? You can talk about English. Okay, English is an English word, right? Good. Okay, how about this one? This is something called okay, a long word, but this is polysyllabic. So how many sounds are there? Okay, so like twinkle. Okay, so this is 2. Okay, polysyllabic. 5. Is that okay? Sun, 1. Moon, 1. Okay, so English word, you can think about this as they are either polysyllabic, more than 1, or there's unisyllabic, there's just 1. Okay, or monosyllabic. Okay, mono. So polysyllabic is a word. It is a polysyllabic word. Okay. And then there is also unhyphenated. Okay, unhyphenated. So whether there is a hyphen inside the word, for instance, ice cream. So when you write down ice cream, so you sometimes have a hyphen inside. Is that okay? There's a hyphen inside, ice cream. So unhyphenated is a word. You don't have a hyphen inside. So it is an unhyphenated word. Is that okay? Okay, so these are adjectives that can describe themselves may be rare, but there are some of them that you can have. Okay, and then okay, so all the others, for instance, long is here. Okay, maybe beautiful. Okay, it depends on your judgment whether beautiful is a beautiful word or not. Okay, but careful it can't be, right? So careful cannot be a careful word, right? So you cannot have a word that is careful. Okay, you cannot have a word that is careless. So you have all the other adjectives that is belonging to this group. So now, okay, so if things are like this, so this one has the same meaning as themselves. So let's call it homological. So this group of adjective, we call them homological. Homo means the same. Logical means meaning, with the same meaning. Okay, same idea, same meaning. And for this one, let us call it this side. Let's call it heterological. Heterological. So heterological means it has a different meaning. Okay, the word has a different meaning than itself. Okay. Everything looks okay, right? Right? So this one is an adjective. This one is an adjective. Now, okay, Bertrand comes. Okay, Bertrand's Rousseau's paradox comes. So this Rousseau asks this simple question. He asks the question: is the word heterological? Is this word heterological? Is it a heterological word? He asked this question. Now, there is a problem. Okay. Now, if heterological really has different meaning from itself, so heterological becomes heterological. Am I correct? Right? But then, so heterological is a heterological word, right? Right? Short is a short word. English is an English word. Heterological is a heterological word. Then that means that heterological becomes homological. Okay. Is that okay? Okay, so heterological, you cannot have heterological at the beginning because you will become homological in the end. On the other hand, if heterological is a homological word, what does it mean? If something is a homological word, that means that you can use it to describe itself. So short is homological, so short is short. English is homological, so English is English. Okay? So if heterological is homological, then heterological is heterological. Okay, if you start with heterological is homological, you will then have what? You will then have heterological becomes heterological in the end. Okay, go back and think. Okay, so this is crazy. Okay, and then so this is again something wrong. So what's wrong? Okay, what is going wrong? If you don't invent these two strange words, homological or heterological, everything is fine. But if you invent this word, and then they are adjectives themselves, and then you need to discuss them together with what you have just defined, then there will be a problem. So this is a problem that comes from self-referencing. Okay? Okay, and then there is one more. I don't know whether this is called a paradox. But then think about this. So we have studied induction already, right? Mathematical induction. So someone gives me this proof. So it says that every positive integer is special. Okay, so this is a theorem that says every positive integer is special. Well, it can't be, right? If everything is special, then everything is not special, right? Yeah, right? So, but then someone tries to prove this. So let's see the proof. Okay, the proof is 1 is special. So what is so special? 1 is special because, okay, 1 times everything is equal to that number. Or 1 square is equal to 1. So this is the only positive integer such that the square, the cube, the 4th times is also equal to itself. Okay, because we don't count 0. Okay, so 1 is special, right? Okay, induction. It says that assume that all the numbers between 1 to k, they are already special. We want to prove that k plus 1 is also special. Okay? You understand the logic? So this is the induction, strong induction. So there are two cases. The first one is the number k plus 1 is special. Okay, if it is special, then we are done because this is what we want to prove. We want to just to prove that k plus 1 is also a special number. Is that okay? And the other case is what? The number k plus 1 is not special. Then what will happen? Now, if the number k plus 1 is not special, then it is super special. The reason is that for all the numbers between 1 to k, they are special, right? So this will be the first number that is not special. So this is very special, right? Right? So this is the first number that is not special, so this becomes special. So that means that no matter the k plus 1, this number is special or not. Okay, given that the first k numbers are special, then the k plus 1 number must be special. So by the what? So done. So we are done with the basis case and also the inductive case. Done. So by the principle of mathematical induction, all the numbers, all the positive integers are special. Okay? So there must be something wrong. Okay, I try to convince myself that what's wrong. Okay, so it's again about self-referencing. So you are defining the word special based on what happens in the previous numbers. So it is not just a standard that you can talk about it without looking at all the numbers before. Okay, so if you define special to be some rule that is independent of all the other numbers, all the special numbers, or whether the other numbers are special or not, then it is okay. But here, in our argument, in our proof, we are saying that okay, a number is not special, but then it turns out it becomes special. This is something that creates a problem. I think this has similar flavor as this kind of paradox that we have, but not exactly the same, of course. But normally, all paradox that we encounter daily, it will have a self-referencing ingredient inside. Okay? Okay, so I hope you like it. So let's end the class early today, and then we continue the discussion on Wednesday. Okay?